So I'll ask my student, Mr. Asutosh, to introduce.
Yeah, sir.
Then you
Sure,
can start this. Okay. Thank you.
Good evening, sir. Dr.
Yeah.
PrabhakarKarthikeyan completed his bachelor's in engineering from the University of Madras, Tamil Nadu in the year 1997. Sir also has completed his master's from the MS University of Vadodara, Gujarat in the year 1999 and has completed PhD from VIT University, Tamil Nadu, India in the year 2013. Under the guidance of Sir, he also has completed his postdoctoral fellowship from the Central Power Research Institute, Bangalore during 2015-16 in Karnataka, India. Sir is presently with VIT University as professor. Sir is a senior member of IEEE, around 45 published articles in Peer Revised Journals and around 80 works in national and international conferences. Sir's area of interest includes deregulation and restricted power systems under smart grid environments, electric vehicle scheduling, and issues related to distribution system studies. Thank you, sir.
Over to you, Professor.
Yeah, thank you, sir. Thank you for introducing me. Before I start my presentation, let me start with a small video file which was done by some students on this PMU. It will be very interactive and maybe throw some enlightenment on how we can also work on such animated videos, which will help our students or others to prepare this as a small project. Okay, so is the screen visible, sir? That power system?
Yes, sir. Yes, sir.
Okay. So this is there are two substations where two PMUs are connected. I hope already you started having a basics on PMU. So that's one reason why I went directly to this video slide. So you can see this waveform gives me the phasor details of the output of this PMU1, and this is about PMU2. Okay, so under normal condition, if you run this is just plotting the voltage and angle at this bus number 1, and similarly bus number 2. And under faulted condition, if I start simulating it, the time is set for some 14 seconds. So once under normal condition, the voltage and angles are coming. So this is something like the data which is obtained from PMU. That's what this video file helps us to show. Now fault is simulated. Now you can see this voltage and angle goes randomly at both the end, substation 1 and 2, under faulted condition. So you can change this magnitude, angle and frequency accordingly. This voltage magnitude and angle will change. So this is one thing. Then if you click PMU, this about the subsystems available within PMU, and in this the ADC section, which has whether filtering or what type of filter you want, accordingly you can select, so that it will generate such a waveform. Then this can be converted into a digital. So this is one. You can see the GPS signals also. You can see the accuracy of the GPS signal, which is useful. So you can see this phasor estimation also. So you can see this estimation, how these values are whatever value which you are seeing it, this amplitude, with this time, these are shown in the form of a phasor diagram here. So this particular video file helps you to show the role of phasor measurement unit and how the data is extracted and how can we utilize these data for future studies or future analysis. So with that introduction, let me move on to okay. So what has motivated this technology to come into picture? Though people, the developed countries like US and including India, still faces severe blackouts frequently. And as you know, in 2012, India suffered with a very serious blackout, and in 2003, there was a severe blackout in US. So what we can understand is the so-called developed countries still cannot guarantee or conveniently say that we are 100% secured or the system is 100% reliable. There are a lot of challenges still comes and disturb the network and create the scope of working or doing research on the power system network. That's the final takeaway from these type of blackouts and other things. And when it comes to real-time control and when it comes to wide area networking, SCADA system is not really suitable for a local generating station. If you want to make it a real-time monitoring, it's okay. But when it comes to real-time, that too for a very big network, this SCADA system fails. And similarly, the rate at which data you want to more amount of data somewhere around 40 or 50 frames per second, that is possible with this technology. And this consists of a phasor measurement unit and phasor data collector, which you call as a PDC. And more interestingly, it provides with this time-stamped phasor information, which means this phasor measurement units, every unit is stamped with the time information. For example, if you take India, uh, uh, actually Indian government are planning for going for a 2 time zones. I don't know what is the status of that. So if you take a people or any failure in the Gujarat or in the failure in this Arunachal Pradesh area, the time stamping with the time stamping, if you want to, if there is no time stamping, the data taken at one place and the data taken at the same instant, but by the time when I receive these two data, if the information about what instant it is taken is not there, then there are chances of failure of taking the two data at the same instant. And this problems comes or becomes very serious when the area of the network is big. So that is the reason why the time stamping play a very important role based on which the data are taken. So real-time decisions can be made or it can be used for some future study. So whatever be the thing, it is this technology is very much useful for the study. So if you see after US blackout, as I said, people started utilizing in the transmission side these PMUs, okay, which are connected with the GPS, that is the satellite, so that people used to extract the information starting from voltage angle, then similarly frequency. So nearly 15 to frequency, then rate of change of frequency, and similarly the voltage phasors, all those phasors for all the phases. So you get all these informations ready-madely. And as I said, there was a severe grid failure. Possibly we might have controlled this by doing certain forensic studies on the data, whatever we have. And for interestingly, if you see, ago, before 20, 25 years, we were running scare of data. Data are flowing in the power system network. So there are challenges, advantage and disadvantage. Advantages, you have now huge amount of data for which you can do a lot of study on that. But the negative is it really a correct data, or if there is any anomaly or bad data is that you need to do certain data mining approach based on which you have to remove the bad data from that. So you need all those studies incorporated so that you can guarantee your analysis. So this always, the word wide area monitoring system is closely associated with this PMU, because we are working on a real-time monitoring and the controlling of power grids. It is basically implemented in managing a large complex network, so that this voltage with a very high resolution, voltage, current, phasor angles across the geographical locations. And this phasor measurement concept, they are associated with the data analytics in power system. It's a separate topic now. People are very much interested in working on this area, that is data analytics, which is totally dominating the power system network. It may be of home energy management, maybe of power system study. Huge amount of data is available now, so which helps us to do a lot of studies, maybe in terms of forecasting or maybe in terms of analysis. Okay, so the main applications includes first monitoring. So you can see the conventional way of monitoring, conventional way of congestion management, state estimation, or fault location, and these islanding techniques. Now, these are all these techniques or these areas are all enhanced by these synchrophasor units. And due to this advantage of this phase angle difference, time synchronization, and fast data rate, so these people started utilizing these PMUs. The only thing is um, the cost of somewhere around 40 plus lakh, and people or a country like India, we could not install it in all the voltage levels. So they started with a very high voltage level. Slowly, we are moving to the voltage, all the voltage levels, and it is also important to know that we are thinking of working on low voltage side, that is on the distribution side, where micro PMU concepts are. Maybe I'll discuss these things later. So you can see this power system operation and control area. We need to predict certain things, because once any issue comes, we cannot wait for that issue to happen and then take a necessary action. So we should have a system such, because it's a matter of economy, it's a matter of human risk, everything. So we need to predict, for which this data analytics are very much useful. So when you're handling with this data, what are the areas which are, first thing is to operate on the system, you need to first sense the information. So basically it should come from the PT and CT, because we cannot avoid these two devices, because basically they act as a sensor. So these two devices takes the information and then give it to the device for populating it to manipulate the data to the required format. And similarly, communication is very important, so that it can communicate with the PMUs or with the other systems. So what is the communication protocols, and how far the standards are maintained, and visualization and control. This is another important area in which people work on the research, how to visualize the data. Because when you have a huge amount of data, if you populate it simply in the form of a data file or a CSV file or something like that, it's very difficult to understand the happenings or monitor the happenings in a quick manner. So you need to project it in a different representation such that you can get the important findings immediately. So for which this visualization of data is another area. So we always aim for a economic and reliable operation. So there are different areas. The parameters, if you take the voltage, frequency, and power flow, these are the main parameters based on which you are, as a system, as we are now talking about in terms of a system, the whole power system network. So we are talking about the voltage and the frequency. When it comes to regulatory framework, then this market operation is there. As you all know, now we have most the power flow is also happening through open market. So these PMU data, oh, I have seen a lot of research workers are happening on the market operation or the stability of the market in terms of PMU informations. So that's also another, because when you say power system stability, we can extend it to market stability also. How far the cost, how far the clearing price, cost is stable. So that sort of forecasting studies, we can do it with the help of the data. So I think this we already discussed on the awareness we should have, okay, based on the situation we have. I think this is the control center, uh, just to get give the glimpse of how the role of power system engineers, or how do they play a very important role in making decision making and monitoring the system situations. It's exactly similar to the space research center. So you can see when you why people started thinking of this, because of the how much power outage and how much affects the money, in terms of money or in terms of the disturbance happens. So that's what this slide shows. So you can see the power outages have risen sharply over the last decade. So that is the though it is a negative issue, but still this has made the power system engineers to work more, to do a lot of research, and the scope of people to work on the power system still exists because of all these issues. And as you know, still these renewable energies, whatever is there, it's intermittent in nature. So on the extreme weather events, so all these things you can do. So particularly people who are doing research or planning to do research after the MTech, you have a lot of area to work with this PMU data, okay, so that you can move on to different areas with respect to these data. This slide is to show you how in US, but this is taken somewhere in 2017 or 18, if I'm right. Uh, so you can, this is just to show the number of PMU which is located in US. So as you know, they are developed, so they are connected in a very huge amount of now in numbers. So these units and data flow in the Northern American power grid. This is just to compare with the cell phone, how this number of sensors which we have in the cell phone, in the smartphones. Okay. Yes. This is one thing we should remember, that when we study about the power system, stability and the disturbance are the key role to understand about the nature of the power system. When we say disturbance, most of the students think, or most of the people think, that only the fault or or electromechanical oscillations happens in the turbine shafts or the disturbance. But even the sudden increase in load or a sudden increase in system can also be considered as a disturbance, because it's all purely depends upon the size of the system and the response of the system, and that impacts the stability of the system immediately. So how far it is increased, when you study the types of stability, you might have come across various types of stability where the increase in load slowly and or a short sudden increase in load can also be affect or disturb the stability of the system. And as I said, when it comes to data analytics, we have now huge amount of data. And again, when you say power system data, it should be highly secured, because the neighboring countries, they can what you call, they can disturb our power system network by injecting bad data inside this, or hijacking the data network and disturbing the network. So in that case, how to identify all those things? So that's a very serious role played by the data analytics in the power system network. If it is, if it is just going to affect in some other application, it's fine. But when it comes to power system, the grid, the volume of power flowing in the grid, and the money on which this invested, or at the same time the economy which is going to be indirectly or directly dependent on the power system, will be totally disturbed. When it comes to classification of PMU, uh, first level, maybe we can start working on the soft PMUs which are available in the RTDS environment, or even PMU models are available. So using those models, exactly, you can work out on, which we call it as a soft PMU. Then slowly, because for the experimental level, you can work on that, and then slowly go into the hardware, real hardware PMUs. And in that, we call it as a micro PMU, and a PMU is used in the distribution system. So I aware that CDAC was in the process of manufacturing PMU in the low cost. I hope it has come to the market, because it was in the process of coming to the market with cheaper rate. CDAC with the central CPRI. So this micro PMU, when it comes, then the whole distribution system also will come under the controllability, and the cost also will come down. There are certain standards also which we should know. What are the different standards? Because as you know, communication is also involved. So there are different standards, and as per the standard, they also define your PMU. And what are the few features? As I said, the phasor representation, time synchronization, then high sampling rate. This high sampling rate is a very key, a very important issue. Okay, when it compared to the traditional SCADA system. So you can see 30 to 120 samples you can get, means per second. Just think of per hour and per day. And using this, you can play with the data, and you can do a lot of studies in the data. It is exactly similar to our human being. When you take the blood level, pressure level, instant by instant from us, and you can completely study how my behavior will be after 5 years or 10 years, or maybe 1 year, what happens to my health. It's exactly similar to this. So the same thing, the power system forecasting, we can do it, or immediately what will happen for a short term or a medium term level. This, when it comes to the data extraction from this rate of change of frequency is another interesting feature which we can extract from this data. Because apart from frequency, rate of change of frequency will give you other more interesting feature, because frequency you will get an immediate information, but rate of change of frequency will give you information about what's going to happen in the near future. So that's more important when it comes to the system analysis. So these are some IEEE standards which governs the PMU and synchrophasor technology, so which is revised in 2014 to know about the performance metrics and the test requirement for PMU, especially on the measurement accuracy, because these are all very important. You cannot have too much of approximation in the data which you are going to receive, because you are going to take very serious decisions based on this, because when it is used in real time, at least for a forecasting it's fine, but when you are interested in doing some real time study and take real time decision, then they play a very important role. So focus the next standard, if you see, it focuses on the communication of the data, including the various protocols and the format, what type of communication you want to do to ensure the interoperability between the PMU and other systems. So we in India, we already have installed PMUs. So this paper, you can get some real-time load balancing strategies for lights with the help of PMU. Okay. So people are working on various other domains where this PMU data can be used for studies. So you can see what are the basic information the PMU measures. One is this voltage and current, so which means three phases. So three voltage and their phasor, three currents and magnitude and angle. Then similarly phase voltage and current, then frequency, then rate of change of frequency, and along with that you can give the status of the circuit breaker and what is the status. So these are all some information which you will receive from the synchrophasor unit. This is a basic block diagram how the PMU units works, and as you know, for a stability point of view, the Nyquist criterion, so based on which that sampling is done. This is a basic block diagram of PMU. So you can see the CTPT, because this is what I also said in the morning about we cannot avoid using this PT and CT, because that is there. Whatever technology comes, the first device will be these two only. And after that, you manipulate with the data and make it suitable for communicating to the next level, and you estimate it and you synchronize it and send it to PDC. All those things are okay. And this is the basic principle of any sinusoidal waveform. You can represent in the form of a phasor, and this phasor information only we are talking about introducing it. So what are the other benefits? Yes, so we can just rethink of whatever study people have did in future. I'm sorry, in the past, like for example, optimal dispatch issues, then power flows, congestion issues, all those things, the protection side, everything can be rethink or reworked with the help of these data, along with the latest techniques. So that can be of another interesting work the budding research people can start thinking of. So you can see adaptive protections settings. System operators can uh, and work on this restoration process. Then yes, this is another important comparison of SCADA system and your PMU. Okay, so this is based upon, you can see you do the number of sampling done per second when you compare with phasor unit and with the SCADA system. Similarly, the synchronization of data, which is not done. This measures both magnitude and phase angle, only magnitude. Basic stability monitoring only is done in the SCADA, but provides detailed grid stability and easily integrates with modern smart grid, and you have a limited version there. So this I have given this purely for people who are interested in doing research on this area, this teaching fraternity. Okay, so this one slide will help you to understand. Okay, because there are different websites, maybe the Kaggle or even IEEE now it has given free data to if you have a login, right? Then you can download a lot of database, and in that one database available is from the PMU data, from either from the foreign. As you know, still it's very challenging to get the data from Indian network because a lot of practical issues are there. But from abroad, you have a huge amount of data available in online, so you can start downloading it. You can start thinking of working in any of these areas. Yes, this is also another different areas which I have mentioned. It can be used. And for a real-time monitoring and control, how this can work, so that how it can be used is been said by a paper which we got from a development and implementation of a phasor measurement unit for real-time monitoring, control, and protection. So interconnected architecture of, so you can see there are different PMUs. You can see this will help you to understand the role of PMUs. What are the things you can do? Tie line power flow from satellite communication. Here also PMU is there. This same PMU you can see here. Then food market. This renewable energy generations. So there are interdisciplinary activity which can be interconnected for this synchrophasor technology. Yeah, I think the same example which we have seen in the form of animation. Okay, exactly. This is been calculated the voltage at one station and another voltage at the receiving end station. Here they are given in the form of a sending and receiving end, so that you can understand these informations. At the same time, these PMUs can be interconnected. Okay, and all the data will flow through a single collector. So you can think of how as the main monitoring system handles this data for a very wide area monitoring of the network. So you can see the present conditions in a number of papers published. People started working on machine learning, and data analytics and physics-based algorithms are developed for anomaly detection from this synchrophasor data. We can see a huge amount of people from computer science background jointly work with power system people on this area, where they see how various machine learning algorithms are helpful in anomaly detection, or maybe to classify the event, because event can be of any nature. So from the data, right, what sort of event might have happened or what can possibly happen. So where your machine learning is very much helpful in go hand in hand with the power system engineer to do these analysis. So you can see the data analytics from the synchrophasor data. So what is basically done is data is collected and this noise removal and synchronization is validated. Then future extraction is done. Then machine learning models trained on the historical data. Then real-time monitoring and prediction is done. This is a general flow of which these data are handled in meeting our objective. There are different way of representing the PMU data in the output form, like box plots, parallelogram, and the formation of clusters carrying out for the PMU data recorded, right? So that's also another interesting. Yeah, I think this is what I was. These polar plots are also used when some disturbance happens on the system, and that should be readable from the PMU data. So you can see based on the frequency, system frequency, this polar plot is very much useful. And this is another way of how PMU data sets are processed, through which to data visualization, feature extraction, then the scaling of the data, then finally you can see training of the model. Then using this Google Colab and Python, you can work on this, because when you are handling huge amount of data, the normal setup, it will be difficult. So when your memory is very high, you go for some GPU based systems, and you do whether your results are accurate or your analysis is accurate, and can measure the performance of these in terms of evaluation metrics. So this is just, we are going into the data processing, how, what is the steps involved in data processing, because this is just one by one we can see, because with the raw data collected, which offers because if you just directly take the data and use it for your analysis, we need to validate the seriousness of the data, how far it is correct, how far it is the real data. So that has to be processed first. So these raw data contribute to enhanced monitoring, enabling grid operators to comprehensively understand the dynamic behavior and the real-time state of the grid. So as I said, these machine learning techniques are very much useful for various applications with the help of the synchrophasor data. One is to identify the unusual grid behavior, then forecasting the grid event, where which you can anticipate the fault, outage, and disturbance. Then load forecasting, as you know, and various techniques can be used, because on a daily basis, new algorithms, new techniques are evolving. So even that has made the analysis very simple. Even some people, without understanding the algorithm itself, we can start working, right, just to see how far these algorithms are superior in nature. So this is just to show that what are the different methods for detecting the events in PME data. There are different methods. So one is machine learning method, time frequency analysis, frequency domain, and statistical analysis. These are different analysis which are very much useful in detecting the event, because there are different event. When I say it's a disturbance, so when different disturbance happens, short-term disturbance, long-term, long. So this is just to show how the synchrophasor data is beneficial for what are all the issues can be solved, or will be interestingly dealt with the help of this data. So exact nature and timing of the fault. Just I'll take an example, this enhanced fault analysis. So instead of normal fault analysis, it can pinpoint the exact nature and timing of fault in faster diagnosing and restoration of power system network. And grid oscillation analysis. This helps identify and study the inter-area oscillation, which are critical for maintaining grid stability. And other than that, this abnormal detections. See, these are all. I want to make the statement very clear that these are all done long before also. Okay, with the normal statistical method or normal techniques. But now we are just moving ahead in a faster rate and most accurate way. Two things: how fast we are, and how exactly and how accurate we are. For these two reasons, your PMU data is going to play a very important role, because these are all, because we had our power system network long ago. Okay, so we were working on the power system also. It is not just with the PMU we are talking about this. It's nothing like that. So RTDS is another system. So it it allows this testing and validation of models or control hardware also. You can interconnect it and see the system, how it behaves. So it also validates PMU performance and the data that generate under different, because as the cost is very high as of now, so we need to place this PMU in a correct position, so it should have a controllability and observability issues before placing the PMU in the grid. So this is what I said, the biggest challenge, the data mining approach for PMU data validation. You can see these price, some data have come down. So probably you can see here also this data. Okay, so is it really a bad data? When you start processing with that, you may, but there's a debate. Data is always a data, so we should include. This is a concept set by some researchers, and some people say that as we know that these are all bad data by some techniques, it's better to exclude that and work on the other real data. So it all depends on our objective and what is our expected plan of working. So these are all the hardware setup through which you can work on this PMU data, and how it can be useful in terms of various communication network used, and how it is interconnected. This slide also will be very much helpful for those who are want to purchase on PMU. GE, Alstom, Siemens, and NI I have come across. Okay, so these are all some vendors, and the conclusion is this is technology has emerged as a transformative tool for modernizing power system by making the system a real-time and synchronized monitoring and control. And this RTDS enables the generation and testing of phasor measurement unit in a controlled and dynamic environment. This is also, this RTDS goes hand in hand. This capability allows researchers and engineers to model, analyze, and validate. So you can see modeling is possible for different, bringing different application accordingly. Whatever modification you want to do, you create a new model, because that platform is also available in softwares, which helps to modify your PMUs. Then from which you can do the analysis with the help of that, and you take a grid, and then with high precision making RTDS generated PMU data. So this is what I said, that the soft PMUs which are available in RTDS. So if you really cannot purchase your actual PMUs, you can work on this RTDS environment through which you can get the data from the PMU, which is more or less similar to the actual PMU data. Okay, for future research in the power system network. So yeah, I think continuous advancement in the communication technology, data analytics, and cyber security, because these are all some key areas where on a daily basis evolution is happening. So when whatever change is happening here, then immediately as a power system engineer we should think of with respect to our objective, because when it comes to cyber security, you have various these devices are all the connection, the packs, everything gets updated in internet. So in that case, when cyber security issues are there, someone from for example Pakistan, they can control or the PMU which is nearby, so that it may give a wrong data. So that will create a serious issue. Okay, if we are not having a highly secured internet things. So yeah, so these are all some references. Yes, this book is available because, as you know, this PMU technology is this whole done by AG Patke. So his book on PMU will be very much helpful those who want to work and do research on with the help of this PMU data. So these are some references. Yeah, thank you for your patient listening.